Is building a thermonuclear fusion reactor actually easier than rebuilding a small block Chevy? And the answer is quite possibly yes. And that does sound ridiculous until you meet the Farnsworth Fusor. Welcome to Nuclear Trailblazers. The baseline knowledge and technical skills required to successfully rebuild a small block Chevy are at least comparable to, and in some respects greater than, those required to build and operate a neutron-producing Farnsworth Fusor. Developed decades ago from the work of television pioneer Philo Farnsworth and later Robert Hirsch, the Fusor is one of the simplest machines capable of producing genuine thermonuclear fusion. At its heart are a vacuum chamber, central grid, and high-voltage feed-through. But even the chamber doesn't require elaborate fabrication. Standard conflat vacuum components can simply be bolted together using inexpensive O-rings, with an assembly complexity that barely rivals putting together a cabinet from IKEA. Even the high-voltage power supply can come from inexpensive ionic air cleaner technology. And the fuel isn't particularly exotic either. Fusors operate on deuterium, heavy hydrogen, and small experimental quantities of this material can even be produced using repurposed hydrogen fuel cell children's toys. And yes, I said that right, children's toys. Operating the machine isn't necessarily difficult either. Once properly constructed, bringing a fusor into neutron-producing operation can be compared to tuning the jets and mixture on a 4-barrel carburetor. You're simply tuning a physical system into its intended operating range. But there is one thing you absolutely have to establish. A glowing plasma is not proof of fusion. You need evidence of neutron production. Electronic neutron detection systems can become sophisticated, but there's an extraordinarily simple alternative: commercially available bubble neutron dosimeters. They're insensitive to the X-rays produced by a fusor, but respond only to neutrons, providing compelling physical evidence that fusion is actually occurring. So no, you do not need to be an Einstein to achieve nuclear fusion. Devices like these will not power your house, and it will not produce more energy than it consumes. But a relatively simple machine sitting on an ordinary workbench can genuinely fuse atomic nuclei and produce the neutrons to prove it. Now, this isn't a how-to video. It's simply a look at what I've learned from building and operating several neutron-producing fusors myself, and just how surprisingly straightforward the process can be. If you found this interesting, please stay tuned for more.